All right, class. Good evening. So, yes, Fahad, where were you? Your exams are over now? Your half-yearly exams. Fahad.
Assalamu alaikum, ma'am.
Walaikum assalam.
No, ma'am, there was a unit test. So today was
Okay.
last.
Okay. UTs were going. So now it's over. And what about your half-yearlies then?
Half yearlies, they said that they will conduct on in November, mid of
November,
November.
mid of November. Okay. So I think your pre-boards will most probably be in the month of Jan. Yes?
Yeah,
Most
yes,
probably. Okay. So as you all will be getting your schedules of pre-board, no, not even the exact schedule, but even if you get the month, you have a most probably we get an idea whenever we are going to have our pre-boards. So whenever you're going to have your pre-boards, just let me know the month so that we can plan out a revision in that manner only. Because now see AC's end, we are towards the end of alternating current. Then EM waves is a shorter lesson. Now in your complete lessons and syllabus that is left, you only have ray optics, which is one of the major topics. Optics is a unit that is left. Half yearly on 15th portion, first 4 chapters. Okay, so till magnetic effect. So did you join the at that time, Priya? Priya, if you require any help regarding any of the chapters, no, let me know. I'll send the playlist as well. On the group, I am sending the playlist. So if you require the playlist as well as the notes or anything, let me know for your exam. All right, Priya. Reem has joined, Rifat, Sahal, and Zaid. Okay. C class, we had started with LCR circuit. LCR circuit was what? It was a combination of purely resistive circuit, purely inductive circuit, and purely capacitive circuit. These three circuits, we had done it individually. What we had seen that when you have a purely resistive circuit, current and voltage are in same phase. Why am I repeating it for the fifth time? Is because this part is important and this is the core part of alternating current. If you're not able to understand this fact that which vector is leading which vector, then the whole concept will become wrong. And you will be having a test also on next Thursday. So be prepared for the alternating currents test also. EMI's result I've already shared on the group. So I think all of you must have seen it by now. All right. So if anybody has not received, let me know. I think it was only Fahad's score which I didn't see. Otherwise, I think rest of the scores I had seen. Fahad, I've sent your score as well on the group. Then we had inductive circuit where voltage was leading by 90 degree, and in capacitive circuit, voltage was lagging by 90 degrees. Now, when you combine all these three factors in a single circuit, that is known as LCR, series LCR circuit. Specify series because here resistor and inductor are not connected in parallel and connected to series with capacitor. All the three are connected in series. Fine. So phasor diagram, we had seen that two cases are possible. Either voltage across the inductor could be greater than voltage across the capacitor, or voltage across the capacitor could be greater than voltage across the inductor. All these things we had seen. The way we had our resistance for the resistance of a circuit, purely inductive circuits, we had XL, inductive reactance, for as the resistance for the inductive circuit. We had a capacitive reactance XC for the capacitive circuit. Similarly, when you combine all these circuits together in a single LCR circuit, then there will be opposition in this circuit as well. Current will be flowing in this circuit and this current will be facing a resistance. When this current will be facing a resistance, what will we call the net resistance of the circuit? We say that net resistance for this LCR circuit, this is Z, which we call as the impedance. So we did those derivations to find out the formula for it. You have to remember under root R square plus, either it can be XL minus XC whole square or XC minus XL whole square. Now, depending upon whoever has the greater magnitude, we use either of these formula. But basic formula is same. Z is equal to under root R square plus XL minus XC whole square. Fine. Then resonance condition we had seen. In the case of resonance condition, your XL and XC are equal, and this is the condition when your impedance becomes equal to the resistance of the circuit. This fact is important because now we will be proceeding after this only, and resistance is one of the major and important topics from your AC. Specifically from LCR circuits, resonance condition is usually asked in the exam, as well as to write the statement of resonance is also asked in the exam. So mark resonance as important, and whenever you're revising, do pay attention to the resonance condition. Anyways, in this case, resistance, or simply you can say impedance for the circuit becomes very less. So if the resistance is very low, somehow you have decreased the resistance. Earlier impedance value was this much. We had the value of impedance as this. Now, since these are equal, we are getting the impedance value as R only. Impedance has decreased. It means resistance has decreased. So there is no opposition for the current to flow in the wire, through the wire. So current becomes maximum. So whenever you are writing and specifying the resonance condition, you have to mention two facts. One fact that XL is equal to XC, and second fact that current becomes maximum. Now from here we have one topic. So numericals and all till here we had already completed. So quick revision is also done. Natural frequencies formula is also important. This whole complete resonance part is important. Please mark it as important. Whenever you revise it, do not leave any of the fact from it. Then you have a term known as Q factor. Q basically stands for quality. This is quality factor. Zaid, if you're not able to understand at any point, you can ask me, as well as if you have to leave in between, just inform me. All right, Zaid?
Okay, ma'am.
So Q factor is the sharpness of resonance. See, this can be understood with the help of a graph. This can be understood with the help of a graph. This is I naught, current on your y-axis. Here, this is x-axis. X-axis has omega. Omega we have been discussing. This is what? The frequency, angular frequency. Linear frequency is that nu. The symbol that we write now, nu. Here we have omega as the angular frequency. Now see, if I drop a graph like this, this is having a very lesser value of current. See from here. This is having a very lower and lesser value of current. So if the current is very less, it means here the resistance will be high. So this makes it high resistance. Let's increase the current. This now current's value has somewhat increased. So the kind of resistance we'll obtain here will be a moderate value of resistance. And if you get the highest value of current, a very high value of current, that means it's a very low resistance. Fine, even if you see this graph. So everything will be calculated with the help of graph. Now, before we go into the details of how to calculate bandwidth and resonance frequency, understand what is meant by this term Q factor, this quality factor. Quality factor means sharpness of resonance, as I've already mentioned over here. Quality factor is simply the sharpness of resonance. See, if you see the variation of current amplitude here, current amplitude is I naught in the series LCR circuit. For this angular frequency, 3 different values of R are obtained. So current amplitude has a peak at the natural frequency. If this is the maximum value of current, it means this is at the resonance, right? Whenever the current is maximum, just now we have revised even that the current is maximum only in the case of resonance. So if I'm plotting the graph with very low value of resonance, lowest resonance, that shows highest current, and highest current simply implies what? Higher value of current simply implies that we have the resonance condition. Now see, so resonance frequency also we had studied. Can anybody tell me what was the formula for resonance frequency? Linear frequency we have discussed. Resonance frequency. One formula was there for resonance frequency. Anybody who remembers, text me in the chat column. Resonance frequencies formula. Yes, correct. It is 1 by under root LC. Right. This is 1 by under root LC. For linear frequency, we multiplied by 1 by 2 pi. All right. So at this value of frequency, we get this maximum value of current which we are continuously referring to. And it falls to 0 in either of this direction. You can see it will ultimately become 0. It will keep on decreasing on the either side of this graph. And this is depicting you the maximum or resonating frequency. I hope the dimensions and all the things that are mentioned in the graph are clear. Now see, the resonance frequency is independent of R, but this sharpness or peak depends completely on R. Understood? The sharpness of the graph is dependent on resistance. How much will the resistance be in the circuit? That will determine your current. If more resistance is there, more obstacles are there, more ions are present, that will oppose the flow of current. So current will be less. So this sharpness depends upon what? It ultimately depends upon the resistance. So peak is higher for smaller values of R and resonance is sharp. This becomes sharp. Sharpness, you understand? Sharpness is depicted like this in the graph. This shows bluntness. So sharp for lower value of resistance. Now, how much sharp it is? This you have understood that yes, lower value of resistance will give you maximum amount of current. And for this, we have resonant frequency. And this is defining as the sharpness because we are getting a very sharp graph over here. But how much sharp is this graph? What is the magnitude of the sharpness or how to measure this sharpness? That is simply given by this quantity which we are discussing, that is your Q factor or quality factor. So quality factor is what? You can have a different definition for it. The definition that you have to write in the exam will be different. Yes, you can leave. Just let me know what afterwards. You can let me know wherever batches and regarding everything. Right now, you are free to leave. Okay, thank you so much. Yes, class. They will contact you. Learnivio team will contact you. Accordingly, you can manage with it. They'll contact you. Okay. So, C class. Now, this we have understood. Yes, maximum value of current is there, lower value of resistance is there. So how much amount or magnitude of the sharpness of circuit is there? That will be given by this quality factor. But now, which definition you have to write in your exam? See, this definition that it will measure sharpness of resonance circuit will not be valid. This can be understood. Let me draw a neat and proper graph again. That graph you have understood, that graph is just to show you that how much is the dependence on the resistance. This is current, this is omega. Now a graph that you have to draw in your exams. This is an important graph. I am just drawing the peak value. See, this is the resonant frequency because maximum value is there. This is some frequency here you have, and here also you have one value of frequency. Name it as something. You can name the frequencies as something. So this can be first frequency, this can be second frequency that has been obtained on the either sides of the graph. Now see, maximum value of current, or you can say peak value of current, will be E naught divided by root 2, right? The maximum value or the peak value that we refer, that is known as what? Maximum value of current. Now for the maximum value of current, what you can do is I naught equal to E naught by root 2, or you can even write IRMS. IRMS is E naught RMS by root 2. times the resistance. Means if you have to write in terms of resistance, you can write it in terms of resistance as well. Now see, what is the definition of Q factor? Understand the definition, then you will be easily able to write the definition. This is a lengthy derivation that it seems. Quality factor or Q factor of a series resonance circuit is defined as ratio of resonant frequency. Ratio of what? Resonant frequency. So you have to take the resonant frequency. Resonant frequency we have studied. This is the resonant frequency, right? So Q factor is ratio of resonant frequency omega R by the difference in both of these resonant frequencies. That is the difference of the the difference to the resonance of the frequencies taken on the either side of graph. So what are the two frequencies that are taken on either sides of graph? Omega 2 minus omega 1. Just write this definition of Q factor in terms of words terms. Now I am repeating the statement. Now see whether you have understood or not. Q factor or quality factor of a series resonant circuit. This is defined as what? It is defined as the ratio of resonant frequency omega R to the difference in the two frequencies taken on both sides of the resonant frequency. Find omega 2 minus omega 1. This is the difference between both the frequencies that is taken on from both the sides, such that at each frequency, current amplitude becomes 1 by root 2 times the value at resonate. It means if at resonance, the value of I naught was E naught divided by, not root 2, I naught divided by R. If the value at resonance, this is the value at resonance, I naught is equal to E naught by R. So such that at each frequency, current amplitude becomes 1 by root 2 times I naught by R. Resonant, that resonant is different. Resonance in physics we usually use for the terms which are matching, like resonance frequencies. Two frequencies are matching. One example you must have done in your class 11th also, tuning fork and the frequency of the sound, that experiment also. The same things. Resonance means some frequencies that are matching. So in this case, what happened? Why are we referring it to as resonance frequency? Because this is the frequency when XL matches XC. That's why we call it as resonance frequency. Fahad, also, if you have missed some lectures as well. So all the lectures, if you want, just let me know. I'll share the playlist with you. You can at least just have a look at all the topics that have been missed by you. So this is what Q is. Omega R by omega 2 minus omega 1. Now, one more thing, class, in this. This definition is clear? See, omega 2 minus omega 1, no, this is also known as bandwidth. This is also known as bandwidth. So if you wish, you can write the definition of Q factor as ratio of resonant frequency to what? Ratio of resonant frequency to the bandwidth. Even you can leave your answer till here. So one more formula of Q we have, but that has a long derivation that we'll see later on. Right now only we'll see once you note this down. That formula, one more formula is there, that also we'll see. But I hope this is clear. This is what Q factor measures how much your sharp is the circuit. How can you write it? Take the resonant frequency divided by the difference of the frequency. Simply like this, you will get the value of the Q factor. Understood till here or not? Yes or no?
Yes, ma'am.
From here okay, good. From here we'll do a derivation. That derivation is important. Not very important from your board's perspective. It is not that important, but it is given in your syllabus. So once we have to do, and before revising for your exam, just have a look at it. It can be asked to you. Chances are less for asking, but Q factors formula can be asked and the definition. Moreover, from this part, we have resonance questions coming. So Q factor has a little less importance, but you never know. Your paper can be made. Your paper is unpredictable totally. So any question can be asked. So note this down. Any queries you have asked me, we'll do a derivation after this. Done till here, all of you? Apart from Reem, what about others?
Done, ma'am.
All right, then I think all of you are done with here. This derivation is a little lengthy class, so that's why let's start with it now. See, this is the formula for Q factor. One more formula. That formula you have to remember. This definition, this derivation also can be asked to you in the exam. There are possibilities. See, at resonance, we all know that Z will be equal to R. Please remember this. At resonance, Z is equal to R. Fine. Now, see, here, if we are referring to at resonance, Z is equal to R. But here, if you notice, this is root 2R. So impedance for now, this will become impedance for this part. This becomes root 2 divided by R. It means we'll not write Z as R. We'll write Z as root 2 R. Because this is for Q factor, the quality factor. Now see, formula for Z was what? R square plus XL, we can write omega L, minus XC, we can write it as 1 by omega C, whole square, under root is equal to root 2 R. Do you all agree? This is the main formula for Z. It's just that I have written XL as omega L and XC as 1 by omega C. Rest of the things are still the same. Now, let's take root on both the sides. So this becomes R square plus omega L by 1 minus omega L minus 1 by omega C whole square. Just we are taking the root on both the sides. So we are left with 2R square. Bring this R square also here. So omega L becomes 1 by omega C. This whole square becomes equal to 2, not 2. This becomes equal to R square. 2R square minus R square will give you R square only. So this becomes equal to R square. Now when you remove the signs, the roots for this R, you get two values. You get the value omega L minus 1 by omega C is equal to plus minus R. That's how we remove the root, square roots. This is how the square roots are removed. Now see class, we have two values of omega. On either sides of the frequencies, we have one value is omega 1, one value is omega 2. So let's substitute both the values in one of these equations. So for 1, we can write omega 1L minus 1 by omega 1C equal to minus R. For omega 2L minus 1 by omega 2C, we can write it as plus R. Fine, you can write it in any manner, ultimate answer will be same. Now, these are two main equations that will lead to our answers. Understood? This first equation and this second equation. See, if you add both these equations, if you add equation 1 and equation 2, fine, if you add both these equations, see what will you get? Add 1 and 2. Okay, class, these two equations are important. Okay, let me know one thing. Till here, it's clear to all of you? It's just, okay. It's just that I have taken the root on the both sides. If you've understood here, now understanding is not difficult. Just add both the equations. See, if you add omega 1 plus omega 2 can be taken common, or let me write all the steps first. If you add 1 and 2, 1 was your omega 1. No, so that becomes omega 1L minus 1 by omega 1C. Plus you have what? Omega 2L minus 1 by omega 2C. You've added them. And on both the sides, you had minus R plus R. Fine. See, from here, if I take from this and this. If I take omega 1 plus omega 2, L as common, we can write it like this. And from these two terms, this term and this term, I can take 1 by C common. Wherever you're not able to understand, just stop me then and there. So minus 1 by C, this is 1 by omega 1 minus 1 by omega 2. Because minus 1 by omega C I have taken common, no. So this will also become plus. If I take minus common, so this will also become plus. And minus R plus R cancels, this is equal to 0. So if I take the LCM, see this part, omega 1 plus omega 2 L can be written here. Let's shift it over here. Since we are getting 0, let's shift it over this side and let's take the LCM. So that becomes omega 1 plus omega 2 divided by omega 1 into omega 2 by 1 by C. This cancels this. Omega 1 into omega 2 is equal to 1 by LC. This was what we were requiring firstly. So omega 1 into omega 2 is equal to 1 by LC. Addition of both the equations are clear to you? Yes or no?
Yes, ma'am.
Yes, only Priyadarshini. Yes, Amin, Fahad, Rifat.
In the second step, we took common, right?
Yes, I'll let me repeat this step. See, in the second step, I have taken common from here. Omega 1 and omega 2. So L has been taken common. So we were left with this. And here 1 by omega 1 by C was taken common. So this was left. Now this whole term was transported on the right side. LCM was taken, omega 2 plus omega 1 by omega 1 omega 2, and omega 1 into omega 2 was obtained. Now, why have we obtained this? This is because now we'll be requiring. Let's subtract these equations. These two equations we have added. Let's subtract these equations. Fahad, is it clear now?
Yes, ma'am. Got it.
Okay. Now let's try and subtract these two equations, 1 and 2. Addition gave us omega 1 into omega 2. Now, if you subtract 1 and 2, see what you will obtain. If you subtract, same thing. See, let me not even write it. Omega 2 minus omega will now be taken common from L. Fine. And instead of minus 1 by C, I'll be having plus 1 by, wherever you had minus sign, that will become plus and plus will become minus. So this will become omega 2 minus omega 1 by omega 1 into omega 2. Got it? Since I've subtracted it, so now omega 2 minus omega 1 was common. Earlier in addition, this was plus. But see, this time this won't be 0. Because when I was adding, it was minus R plus R. So this gave me 0. But this time this will be what? It is R minus R. R minus R. So this becomes equal to 2R. So this time, this is the difference that will come. This is not equal to 0. Understood? This is not equal to 0 this time. Let's do one thing. We can take omega 2 minus omega 1 also common from here. Because now they won't get cancelled. So at least we can do one thing. We can take common. So omega 2 minus omega 1, if you take common, from here you will be left with L. From here you will be left with plus 1 by C omega 1 omega 2. This is equal to 2R. Understood? Omega 2 minus omega 1 is taken common. So we are left with only capital L. And from here we are left with 1 by capital C only. Fine? This is equal to 2R. Now what we had got? Omega 1, omega 2. That's why we had to add these equations. Now it will be for our utility. Omega 1 into omega 2 is what? This is 1 by LC. So now if you write omega 1 into omega 2 as LC, we had got it, no? 1 by LC we had obtained. Put it over here. One more thing. Samya, are your exams going on in school? Samya?
No, ma'am.
Okay, you were leaving the classes earlier. That's why I was asking. I thought you were having your exams. So omega 2 minus omega 1, L plus 1 by C is here. Now instead of omega 1 into omega 2, let's put the value. That becomes 1 by LC, right? 1 by omega 1 into omega 2 will be what? LC only. So LC I've kept here. This is equal to 2R. So C gets cancelled. Omega 2 minus omega 1 multiplied by 2L. This will become 2L. L plus L becomes 2L. This is 2L. 2L is equal to 2R. From here, you can even cancel 2R. See what have we obtained? Omega 2 minus omega 1. We have obtained omega 2 minus omega 1 is equal to R divided by L. Resistance by L. So omega 2 minus omega 1. Remember, we can use this omega 2 minus omega 1 in the formula we were having. Now, before we substitute and get our final answer, till here the lengthy derivation was there. Now we just have a very short part to conclude it. First, tell me, this subtraction part is clear to all of you?
Yes, teacher.
Okay then. So if this is clear, if anybody has any doubt, let me know at any of the steps. Because this is a lengthy part, that's why I'm asking you in bits. Now see, omega 2 minus omega 1 is RL. So qualitative factor was what? Omega R by omega 2 minus omega 1. So you can write omega R means at resonance multiplied by L divided by R from here. First, one of the formula is this also, as well as one more formula we get it. See, this is also important. One more formula that we get it. See, omega at resonance is equal to 1 by under root LC, right? Also, if you take the square, omega R square, it will be equal to 1 by LC, right? If you square both the sides, root will be gone. Here a square will come. If I write it like this, omega R into omega R is 1 by LC. There is no harm to write like this. Let's shift certain terms. Let's just shift certain terms. Let's bring this L in the numerator and take this 1 omega R in the denominator. So we will be left with what? Omega R L is equal to 1 by omega RC. Right? I have just substituted the terms. It's the main resonant formula only that is going on from here. It's just that I've substituted the terms. Omega RL, this can be written as what? From this equation. Q multiplied by R also you can write. From this you can write it as Q multiplied by R. Or you can do one more thing. So if you see from here, Q will become equal to what? Q will be Q, which is equal to omega R L by R. Instead of all this, put value of omega R here. Understood? See, Q's value is omega R L by R. So omega L, put it from here. What is omega L? It's 1 by omega RC. So this becomes 1 by omega R into RC, right? This term I've just added. Here I have substituted 1 by omega RC. So 1 by omega RC has been substituted. Resistance was already present. This, if you solve furthermore, this is also written as 1 by R under root L by C. So many formula for Q factor you can obtain. See class, I'm repeating this part. This end portion I'm repeating. See, till here this was done, R by L. This was the formula for Q factor, omega R by omega 2 minus omega 1, right? So I have just kept the definition and the formula that we have obtained for omega 2 minus omega 1 as R by L from here. This is done. This is also one of the formula for Q factor that we were deriving. Done? From the normal formula of resonance we can write the value of omega RL that is resonant frequency into inductance as 1 by omega r into C. So if you keep it over here, you get Q as 1 by omega r into RC. Also, if you expand it further, take the calculations, put the value of resonant frequency after solving, you can obtain this value as well. This is obtained by putting or substituting the value of resonant frequency. So that's how you obtain all these three formula. From here, this formula is very important and this formula is very important for quality factor from all the formula for quality factor that we have done. Now tell me, any doubts till now? Because once you will write, then it can happen you will be facing any difficulties. Till now, any queries you have, any step you have not understood? Here, Samia, Reem, Fahad,
Yes, ma'am.
Wafia, Sahal, clear to both of you as well?
Yes, ma'am.
Okay, Samia. It was because of internet. Yes, because in the last part of the classes, I'm noticing that you were getting disconnected. So it must be because of the network issues only. Because tests are also you're appearing in every class you are attending. At least if it's like you have joined every class. It's not you have taken a big gap. So it must be your internet connection. That's why I wanted to ask you. Because at the end of the class, I'm observing your internet gets disconnected and you leave before the class ends. That's why I wanted to ask. Okay. Okay, if it's clear to all of you, do one thing. It's a long derivation, I agree. Try to learn whenever you're doing it. No, try to learn in this part only. Addition part, first part, then addition part, subtraction part, and ultimate substitution. In these four parts, try to remember this long derivation. And in whichever step you get stuck, let me know. I'll repeat this step. Because I think for 15 minutes we have been doing this only. So it can happen, some part will be confusing. Text me done once you complete it till here. Q is equal to 1 by R under root L by C. When one formula based numerical we'll do. Others have also completed. I think only Reem and Wafia have texted. Others, okay, Samia. I think most of you have completed. Amen. All right, I think let's do a numerical then. Rifat has also completed. If anybody is writing, just stop me, frankly. I'll stop them. Very, very easy question. This is formula, completely formula based question it is. In a series LCR circuit, the resonance frequency is 800 hertz. All right. The resonance frequency is 800 hertz. So omega R is 800 hertz. Half power points are obtained at frequency. The half power points means power we have not done. That's why we are not able to understand this. Once we will do power, then this will be clear. Why are we referring these points are as power, half power. This is nothing. This is simply frequency 2 is 855 hertz and frequency 1 is 745 hertz. And Q factor is asked and bandwidth is asked. See, Q factor will be omega R by omega 2 minus omega 1. That makes it 800 by 855 minus 745. That becomes 800 divided by 110, which is equal to 7.27. I think this will be, see, it should be around 7.27 only. And see, bandwidth is what? Bandwidth is simply omega 2 minus omega 1. So if you see bandwidth, yes, 7.27 of Ahad? Okay, thank you. So bandwidth will be what? Bandwidth is simply this omega 2 minus omega 1. So that will be 855 minus 745. That will be 110. So bandwidth will be whatever is in the denominator. All right. So copy down this numerical, all of you. So this was all about Q factor, quality factor. Derivation is lengthy, I agree, but formula is important. This formula especially. The formula that I've marked as important, no, these do make it separately highlighted. All have completed till here?
Yes, ma'am.
Okay, so I hope this topic is clear. This is not as important as the other topics of this. Before this, we had completed resonance, but any question can be asked to you in the exam. So be prepared before you just revise it. Once you glance through your notes, do revise it. And in this also, something that you have to remember for your exams and UTs also, the formula part is more important. Derivation of this is less asked, is the frequency of this derivation asking is lesser in their exams. Resonant part is more. The natural resonant frequency part, that is very often asked in the exams. Okay, now these very few small circuits are there. Let's just complete with it. 15 minutes are there. Let's complete with this. See, now these circuits are very, very easy to understand. You have done LCR circuit, and all those students who have honestly understood LCR circuits, for you all understanding LR circuit and RC circuits is very easy. Here in LCR circuit, just remove C, capacitors component. What are you left with? This will be left with, you will be left with a resistor and an inductor. In case of resistor, current and voltage will be in same phase. In inductor, voltage will be leading the current by 90 degree. This will be the circuit. Supposedly you have just cut the capacitor part. All right, in LR circuit. See, derivation and everything is very easy. Here, what will happen? Let's say this is your resistance, voltage. Okay, let's take the voltage also. VR also we can refer. And we are talking about LR circuits. See, for LR, wherever you not be able to understand, please stop me. And for inductor, this will be like this. This will be for VL also you can say, and XL also for resistance you can mention. Fine. Also, if you do the derivation, see, derivation becomes easier than your derivation for LCR circuit. So it will become a revision also for LCR circuit with just a deletion of the capacitor component. Now, you won't have VC square. Remember, we used to have VL minus VC whole square or VC minus VL whole square, either of these depending upon whichever had the greater magnitude. Now, VC is not there, so only VL will be there independently. So now E naught square will be equal to I naught square R square plus I naught square XL square only. This much you will be having. Take I naught square common from here. R square plus XL square. Let me repeat what we had for LCR so that it can be a revision. For LCR, we had one more component along with it. We had XL minus XC whole square along with I naught square. Why? Because VL was not here separate. You had VC. Understood? So that this part has now been deleted. So you will be just left with this one portion. So these RC and LC circuits are very, very easy once you have completed LCR circuits. From here, take I naught square will be equal to E naught square divided by R square plus XL whole square. From here, we can write the value of I as what? I naught is written as E naught divided by under root R square plus XL square. So value of impedance will be what? Z will be equal to under root R square plus XL square. Was somebody asking something?
No, ma'am.
Okay. So under root R square plus XL whole square. Otherwise, we had XL minus XC whole square. So that part is not there. So easy calculations now. That's what I'm saying. LCR circuit, please have a command on LCR circuits and please prepare your alternating current. Most probably on next Thursday, we'll be having a test of AC. 20 marks test I'll be conducting. So now, as I've already alerted you earlier as well, that as soon as we complete this chapter, we'll be having a test. So I think by next Thursday, you will be having a test. Fine. So please start preparing for all these topics. Now tan theta will also be VL divided by VR, which will be XL by R. You will not be having XL minus XC by R. Fine. Now impedance value will be changed. This derivation, this hasn't come till now. But even if it is asked, the small part of derivation you can prove. If you know LCS circuit can come. So for you all people, this is very easy to deal with. One question we have, calculate impedance of the circuit. Okay, and phase angle between voltage and current. Now what do we have? See, this is a resistor, this is an inductor. So voltage across the resistor is given as 90 volt and voltage across the inductor, this is given as 120 volts. We can do one thing. IRMS is there, fine. Let's actually calculate the value of impedance that is provided. Fine. Or do you want to note down till here so that any doubts are not left? From here, you can note it as well. Okay, let's just complete with the question now. Since we have started with it, then you can write it down. Which graph? Which graph, Fahad? This one you're referring to?
Yes, ma'am.
Oh, this is not a graph. This is phasor. Phasors class, did you attend, Fahad?
No, ma'am. I have to watch the lecture.
Yes, that's why you were not able to understand. See, phasors, I'll tell you in very brief, but I think by this it may happen that you'll not be able to understand. Just watch the lecture and let me know. See, if we take the resistor here, no, then inductor is always drawn over here and capacitance is drawn over here. This represents that in case of circuit having a capacitor, it lags by 90 degrees. That's why we draw it here. And for inductors, we draw it here because in case of inductors, voltage leads by 90 degrees. So we had a complete class on phasors and phasor diagrams. So I think just attend that class, or I'll send you the video lecture if you require. So that's only. Now only inductor and resistors are there. So capacitor part I have not drawn. Okay. I think let's complete with the question so you can write it in one since we have started with the question. All right. So VR is 90. This is 120. So let's calculate first the resultant voltage. See, voltage will be what? EMF. VRMS will be what? Under root VR square plus VL square. That's what with which we had started the circuit. So that becomes 120 whole square plus 90 whole square. They are forming Pythagorean triplet, no? 150 volt should be the answer. IRMS is 3 amperes. So Z will be what? See, IRMS is equal to VRMS divided by Z. So Z will be equal to VRMS divided by IRMS. VRMS is 150, IRMS is 3. So this becomes 50. 50 ohms, because impedance is what? Impedance is the obstruction in the resistance that you obtain. Fine. Now one more thing. We have second part as well. No, in here. This was the first part. Second part asks us what? Phase angle. Phase angle. See, phase angle can be given by tan phi. This can either be written as XL by R or it can be written as VL by VR. So we'll prefer with VL by VR. Inductors one is what? 120 and this is 90. So 4 by 3. Yes. So from here, phi can be written as tan inverse 4 by. All right, so this is simpler. For all those who have missed the classes, please let me know. I'll share the video. I'll share the video lectures on the group. Or you can ask me, text me personally. All those students who want the lecture, text me personally with the name of the lesson. I'll share, because otherwise, understanding this is a very easy topic. So if you're not able to understand this, it means that is just because of lack of classes and nothing else. So start noting down from here. Series RC, we won't practice any numerical. I'll just show you how to do it, because it is exactly based on this with the capacitor. Then we'll end the class. So quickly note it down. Okay, your time is almost up. Series RC we'll do in the next class. Quickly note this down. As soon as you will complete the writing part, just text me done. And just you can all leave the class. Your time is already up. On Tuesday, we'll complete the rest of the lesson. Okay, Samya. All those who have completed, you all can leave. Thank you so much.
Thank you, ma'am. Allah Hafiz.
Okay, Allah.
Ma'am, could you please send the playlist of this batch?
Yes, I'll send the complete playlist of this batch. And from where? From there, whatever lessons you have missed, you can see the lectures. And if you require the part, you can skip it and see. Just but have the questions with you at least in your notes. All right, Fab.
Yes.
Oh,
Done, ma'am.
okay, then okay.